Hi, my name is Chris Galam and I'm a product manager at imtmedical. Today I would like to show you the effect of gas standards and how they differ to gas properties in doing flow measurements with both the PF300 flow analyzer and the Cytrex flow measuring device. We will work through a PowerPoint presentation and I will explain you the difference between gas standards and gas properties. When we do flow measurements with any kind of calibrator or any kind of flow measuring device, we have to differentiate between two things, and that's very important. We have on one side, we have the gas properties. That's the actual properties of the gas. That's the gas type, which can be air and oxygen. It can be nitric oxide, different kinds of gas. That's the gas type. Each gas type will have a density and a viscosity which influence the flow measurement. That has all to be known to the calibrator. Then the gas will also have a temperature. It will have a humidity. It may have, and particularly in the case of ventilators and anesthesia machines, it will have a percentage of oxygen which may be variable. And the gas may even have other properties which affect the flow measurement. We'll go through these effects one by one in later slides, but important now is to understand that these are the gas properties. Now, the gas is measured, and inside the flow measurement device, all these properties are normalized into what we call standard liters. Now, we also have something on display, and what we have on display should ideally match with the device we want to calibrate or we want to compare with. So we need to have a standard for displaying, and this is the gas standard. The gas standard determines how these standard liters are recalculated and rescaled in order to be displayed. The important thing to understand is that the gas standard can be completely different to the gas properties, and they have nothing to do with each other. I can take a humid and warm gas, humidified and heated, for instance, and I can display it in a cold, dry gas standard. That's not a problem, but this gas standard has to match the ventilator or anesthesia machine I want to calibrate. If the gas standard of the anesthesia machine is warm and humid, which could be a ambient temperature saturated, ATP-S, then I have to set my calibrator to the same gas standard. The gas which flows through is a different story. Now that's the gas properties, how the flow is measured. Let me go into a little more detail here. That's the effect of pressure and temperature. A lower pressure or a higher temperature makes a volume bigger. So the same amount of molecules will take a higher volume. For instance, 400 milliliter at 30 degrees Celsius will be only 387 milliliters at 20 degrees Celsius. And the same goes with pressure. At a lower pressure, the gas has a higher volume than at the higher pressure. We compress the gas. And that all has to be known. Both PF300 and Cytrex include pressure and temperature measurement to compensate for this effect. So the user does not have to worry about the temperature nor the pressure in a gas. It's automatically measured and compensated when calculating the volume into standard liter for later on displaying in whatever gas standard. Same goes for humidity. Humidity has an effect. A dry gas at body temperature, maybe 400 milliliters. A humid gas at the same temperature, maybe less, or not maybe, it will be less. This is the same difference like when you have the wrong gas standard set. If you have a body temperature dry, instead of a body temperature saturated, you will make a certain error. The humidity, like in this case, is only measured by the PF300. In the case of Cytrex, it has to be set manually. Again, here the difference is not very big, but it should be taken into account for very precise measurements. As a next, we look at the effect of gas type. If for some reason we forget to set the gas type and we measure CO2, but the device is still set up for air, we make a significant error of about 20 to 25%. The gas type has to be entered manually, and that's why it can be forgotten. So the normal thing is air and oxygen, especially when it comes to ventilators and anesthesia machines. Air and oxygen can be set up manually, but it also can be set up automatic by using the built-in oxygen cell. Then, if we use nitric oxide or heliox or H2, so this has to be set up manually. All the other gases have to be set up manually, except this one, where the oxygen cell can also be used for automatic adjustment of the oxygen content. So gas type makes a very important influence. Now let's have a quick look at the influence of oxygen. For example, if my oxygen cell is not calibrated properly and introduces a small error here in the oxygen percentage, I will get an error as well in the flow measurement, because the oxygen has to be compensated. 400 ml at 21% will be 412 ml at 80% with the same number of molecules. So there are influences in all directions. Oxygen is measured automatically by PF300 and Cytrex, and later on we will see in a practical session how to calibrate the oxygen cell of both devices. Let's have a quick look at the gas equation. This gas equation is the basics of everything. We see that a number of parameters play a role: pressure, mass of the gas, specific gas constant, temperature, vapor, partial pressure of vapor, which is humidity, at a certain temperature. There is a number of effects which are not linear, and I don't think it's very important to understand this equation, but it's important to understand the effects several parameters can have on a precise flow measurement. Let me give you an example. If Cytrex is set to measure a dry gas at 22 degrees Celsius, and instead I measure pure oxygen, the error is not very big. Instead I measure CO2, the error is very big. If I have another gas standard set, the error can be up to 12%. So again, the effects of gas and the effects of the gas standard can be significant, but they rarely are more than, well, they can reach 10 to 12%, but that's just about the maximum there is. The wrong gas, however, can make a very significant influence. Good practice rules is select the right gas standard for the measured gas and for the display. So select the right gas properties and select the right gas standard for displaying. A brief example: we were called once by a hospital because they saw a difference between a patient proximal monitoring system of an anesthesia machine, which was measuring 620 milliliters, and the anesthesia machine itself, which was measuring 540 milliliters. They were concerned because they did not know which one was the right value, same or different. We investigated into the accuracy of both systems. The ventilator, or in this case the anesthesia machine, had a measurement accuracy of 10%, and the patient proximal monitoring had a measurement accuracy of 6%, and even with the error bars introduced here, there was little overlap, and it was not very convincing whether this was the same or not the same. And then we found out about the gas standard. We found out that the ventilator displays the value in ambient temperature, pressure, dry, and the patient proximal monitoring system was measuring in body temperature, pressure, saturated, BTPS. Now what we did is we took the ventilator value and we displayed it in BTPS, and all of a sudden it's the same. So concluding, 540 milliliters is the same as 620. Only because of gas standards. This was not even gas properties, this was only gas standard. It was exactly the same gas flowing through the ventilator and flowing through the patient proximal sensor. Exactly the same gas, measured in different ways or displayed in different ways. Once you have it standardized and sorted out, it is the same. This concludes my little presentation on gas properties and gas standards. And I would like to invite you also to join the next presentation where we do this all in practice. Thank you very much for your attention. I wish you good luck in measuring precisely gases flows with both the Cytrex and the PF300, and stay tuned. Thank you.